Good morning, children. Thought for the day. Where there is a will, there is a way. Of course, you must have observed where you wish to do something, you put in all your efforts, and where you wish to do something and you put all your effort, still you are not tired, still you do not become impatient. So, what is most important is your will. So, have strong willpower and find your ways. With this thought, let us continue with our chapter Current Electricity. Up till now, we have studied potential. Just like water, the flow of electric charge between 2 points depends on a kind of electric level at those points, and this level is called electric potential. Next, we have studied is potential difference. The difference in potential between the positive and negative terminals of a cell is the potential difference of that cell. And this potential difference is caused by the chemical reactions occurring inside the cell. Next, we have studied about free electrons. Every atom of a metallic conductor has one or more outermost electrons which are very weakly bound to the nucleus, and these are called free electrons. Current flowing through a wire. We have observed that electrons, they move randomly in a wire. A wire here is a conductor. So electrons, they normally randomly move. But as soon as they are connected to a positive and negative terminal, that is a volt difference, potential difference is created, electrons all move in one direction. And motion of electrons after applying a potential difference to the two ends of the wire is in one direction. And this flow of electrons through a conductor is nothing but electric current. Current, SI unit for it is coulomb, that is C, and current is expressed in ampere, that is capital A. Resistance. Resistance is the resistance offered by the conductor. Okay, so although there are certain atoms in the conductor which will have free electrons which are ready to move, but some atoms will not have free electrons. So while the free electrons are moving, they will face some hurdle in their path, and that hurdle will offer them resistance to their flow. And this is the resistance of the conductor. And this resistance is, there is a relationship between the current flowing through a wire and the potential difference across its ends. And this relationship can be obtained from the law, that is Ohm's law, which states that if the physical state of a conductor remains constant, the current I flowing through it is directly proportional to the potential difference V between its two ends. Then we have studied about the electric circuit, which is the continuous path of an electric current through conducting wires connected to the two ends of a cell, and the other resistances is called an electric circuit. And lastly, we had studied about conductors and insulators. Conductors are those substances which have very low resistance, and insulators are those substances which have very high resistance and through which current cannot flow. Now let us move further and study the experimental proof of Ohm's law. Okay. For this, a video has been attached wherein the experimental proof of Ohm's law experiment has been shown. Solved examples. Ohm's law and resistivity. The resistance of the filament in a light bulb is 1000 ohm. If the bulb is fed by a current from a source of potential difference 230 volt, how much will it flow through it? Current. So we have to, what have we to find out? Current. Resistance R is 1000 ohm and potential difference is 230 volt. We know that current I is V divided by R. So it is 230 volts divided by 1000 ohm. So the division comes to 0.23 ampere. Next, the length of a conducting wire is 50 centimeter and its radius is 0.5 millimeter. If its resistance is 30 ohm, what is the resistivity of its material? The length of the conducting wire is 50 centimeter and the radius is 0.5 millimeter. Now first we need to convert these units. Length is in centimeter, we need to convert it in meters. We know that 100 centimeters make 1 meter. So 50 divided by 100, okay, or 50 multiplied by 10 to the power minus 2 meters. Radius is in millimeters. So that has to be converted in meters. We know that 10 millimeter make 1 centimeter and 100 centimeter make 1 meter. So 10 multiplied by 100 is 1000. So we'll have to divide 0.5 by 1000 and hence 0.5 multiplied by 10 to the power minus 3. Resistivity, we have to calculate rho is RA divided by L. Now what is A? A is area. Okay, now area here is pi r square, formula for area. So that is value of pi is constant 3.14 and radius we already have, resistance R we already have, and after substituting the values we get the answer as 4.71 into 10 to the power minus 5 ohm meter. So this is the resistivity of the material. A current of 0.24 ampere flows through a conductor when a potential difference of 24 volt is applied between its two ends. What is its resistant? So volt V is 24 volt, it is given. Current I is 0.24 ampere. R is equal to V upon I. So 24 divided by 0.24. So the answer comes as 100 ohm. Okay, because 24 divided by 24 is 1, but in the denominator it is 0 point and it is 2 decimal places. So when it comes from denominator to numerator, it will get multiplied and hence it will be 100 ohm. Next, determine the current that will flow when a potential difference of 33 volt is applied between two ends of an appliance having a resistance of 110 ohm. If the same current is to flow through an appliance having a resistance of 500 ohm, how much potential difference should be applied across its two ends? Now V is equal to 33 volt and R is equal to 110 ohm. In the first case, I is equal to V divided by R. So it is 33 divided by 110. That value comes to as 0.3 ampere. This is the current flowing. And in the second case, current is, we have to use the same value, that is 0.3 ampere, and resistance is 500 ohm. So we know that V is equal to IR. So if you multiply these, you get the potential difference of 150 volt. Next, determine the resistance of a copper wire having a length of 1 kilometer and a diameter of 0.5 millimeter. Rho is the resistivity of copper, which is 1.7 into 10 to the power minus 8 ohm meter. Converting all measures into meters, we get L is equal to 1 kilometer. So you have to convert kilometer into meters. We know that 1000 meter make 1 kilometer. So it becomes 10 to the power 3 meter. Diameter is given in 0.5 millimeter. We have to again convert it into meter. So it is 0.5 divided by 1000, that is multiplied by 10 to the power minus 3. And now area of the cross section, okay, it is pi r square. Value of R here diameter is given, we know that diameter is double of radius. So radius will be d divided by 2, its whole square, and the answer comes as 0.2 into 10 to the power minus 6 meter square. And now we put up these values in the formula and we get the answer as 85 ohm.